All right, recording is rolling. So welcome to Thursday, April 13th. So we're actually a few minutes into class. We got an NCAT class today, starting in with a couple of videos so you guys can see a little bit about the history of electricity. So you guys just watch one of those. We're going to do the circuits review. I'll take you guys through 5 circuits. Now you guys know tomorrow there's Open Notes quiz. It's mostly conceptual questions we'll be going over the last couple of days, and there will be a circuit on there. So circuits review today should cover that. Okay. And so I gave you guys some paper, in case you didn't have any. Okay. And again, we're about to do 5 circuits here. So let's start with this. All right. Draw it so you guys can draw along with me if you like. All right. Let's call this resistor A, B, and C. I won't do capital R for resistor. I'll just label the letter. Right? Let's have an 18-volt battery, 18 volts. Let's call this guy 3 ohms, 3 ohms, and 3 ohms. Okay. And then let's get a table going. All right. So we got different locations, resistance in ohms, potential difference in volts, current in amps, power in watts. Okay. Oh, so we got locations A, B, C in the battery. I gave you guys each of those resistors as 3 ohms, and you have an 18-volt battery. Okay, that's all the givens. Okay? So you guys have rulers or some kind of straight edge on your desk. You guys can draw that whole Kirchhoff table. So we got a circuit, we got a Kirchhoff table going. Okay. We're going to analyze what's going on at every point in the circuit. All right, guys got that so far? All right, first thing, what is the equivalent resistance from the point of view of the battery? The battery feels like it's pushing against how many ohms? Well, if you have 3 in series, isn't the rule just you add them up? Well, any resistors in series, you just add them up, right? 3 and 3 and 3 is 9. Is that 9 ohms resistance? Okay. So the battery is pushing against a total of 9 ohms. Okay. All right, voltage drop. Okay. Break out a waterfall model, exactly what's going on. This could be the waterfall model for what we're doing, right? So we have 18 volts up, and it's going to drop down a little bit, a little bit, a little bit. Okay. The 3 drops have to add up to how many volts? 18. Okay. Now, since the resistors are equal to each other, do you think these drops are also going to be equal? They'd have to be, right? Because right. So do you think it's going to drop? What's 18 divided by 3? 6. Okay. It's going to drop 6 volts there, drop 6 volts here, and 6 volts here. Okay. So that if you follow Kirchhoff's loop rule, right, if you go all the way around the loop, the voltages should zero out. Right? So we got 18 volts up, and then 18 volts down. Okay. 18 up, 18 down. Okay. Is that okay. We get a bit more specific. You could have, like, what if these weren't equivalent resistors? Okay. Well, the voltage drop would be proportional to each resistor. So I'll go ahead and run the math for one of those anyway. So the voltage drop across resistor A, for example, okay, that guy's 3 ohms compared to 369 ohms. So ohms, ohms, okay, of a total 18 volt drop. A third of 18 is 6. Okay, so that's that 6. And you could do the same thing for the other ones. Okay. Guys good there? Okay, so now we know the voltage drops. Next column, the current in amps. How have we been getting current in amps? What do you do? What divided by what? Is current equal to voltage divided by resistance? That's Ohm's law. Is that Ohm's law right there? I equals V over R. Okay. 6 volts acting on 3 ohms. Is that like 2 amps? Okay. How about here? 2 amps, 2 amps. How many amps through the battery? What's 18 divided by 9? Also 2, right? In fact, anytime you have just a straight series setup like this one is, it's the same current everywhere. In this case, it happens to be 2 amps. That's kind of like 2 gallons per minute or 2 cars per minute. Right? I'm using analogies for some kind of flow rate because that's what current is. It's like a flow rate, right? And finally, power. You could do, well, power is current times voltage. You could also do power is current squared times resistance, or power is voltage squared divided by resistance, right? Let's just do a P equals IV, right? Current times voltage. So you got 2 amps times 6 volts. There's 12 watts. Right? So try to stay a step ahead of me, but I guess they were step right. Doing this all a week here. 2 amps times 6 volts is 12 watts there. 12 watts there. All right. And now this very last cell. Remember I told you guys there's 2 perspectives I've been taking you guys through the cell. You could just apply Joule's law at the point of the battery, which would be how many watts? 36. There you go. 2 amps times 18 volt, 36 volts. Right. The other perspective you could do is say, does electricity supply match electricity demand? So I have 36 watts supplied here, and then a collective 36 watts demanded there. Right? You guys see that? All right, there we go. All right. Any questions on that circuit? All right. All right, next one. I want to do another straight series setup, but make it a little more complicated. Not too bad. Okay. So let's do another series setup. Let's go 12 volts. There's resistors in here. Okay. Let's have resistor A be 1 ohm, resistor B be 2 ohms, and resistor C be 3 ohms. How about that? Okay. Okay. Now let's make a whole Kirchhoff table. Got locations, resistance in ohms, potential difference in volts, current in amps, power in watts. So we got A, B, C, and the battery. The battery, of course, is the voltage supply. I gave you guys 1 ohm, 2 ohms, and 3 ohms, and also a 12-volt battery. Okay, so I'm done with the black ink. Let's break out the pink ink and see what gets off from that. Okay, so everything on the board already is what would be given to you. All right, first question. What is the equivalent resistance from the point of view of the battery? How many ohms? Yeah, 6 ohms, right? Just very simply add them up because resistors in series, just add them up. 1 plus 2 plus 3, 6, boom. Okay. All right. Now voltage drop. Okay, now this one's a little trickier than the last one we did. Let's see if you guys can figure out before I get to the answer, but I'll go over it with you right here. So the voltage drop across resistor A, for example. Okay. I'm looking at this rule right here. The voltage drop is in series is proportional to each resistor. Okay. Now, in parallel, those voltage drop same everywhere, but we're not there yet. Right? We're just doing series, so it's going to drop down proportional to the resistance. It's going to be a taller waterfall per each greater resistor. Okay, so this guy's only 1 ohm, so I'll do 1 ohm compared to 1, 2, 3 is 6 ohms along that entire branch. So I think 1/6 of the entire voltage drop happens across this one of 12 volts total. Well, guys, what's 1/6 of 12? 2 volts. So there's 2 volts drop right there. Okay. And then if you double the resistance, this 1 can become a 2. Right? What do you think happens to the voltage drop? What number goes right here? What's double of 2? 4, right? Because the fact that each voltage drop is proportional to each resistor, if you double the resistance, you're going to double the voltage drop. Okay. How many volts drop here? Good. Okay, so 1 to 3, that's an increase of 3 times. What's 3 times 2? 6 volts. Right. Now let's think about this in terms of the loop rule. Okay. So I have 2 volts drop, 4 volts drop, 6 volts drop. Guess what is 2 plus 4 plus 6? 12. Ah, I got a 12-volt battery. Look, 12 up, 12 down, 12 up, 12 down. You guys see that? You guys not? Okay. Current is equal to voltage on resistance. So we got Ohm's law going on right there. So can we do 2 volts on 1 ohm is 2 amps. 4 volts on 2 ohms is 2 amps. 6 on 3. And how about through the battery? How many amps through the battery? It's also 2 amps. 12 over 6 is 2. Oh, and just like the previous circuit, because this one is also a series circuit, just straight series, the current has to be the same everywhere. That always had to be the case. That's my Kirchhoff rule. The current's the same everywhere as long as you're in series. Power is current times voltage, or current squared times resistance, or voltage squared divided by resistance. Same thing. So 2 amps times 2 volts, 4 watts. 2 amps times 2 amps times 2 volts is 4 watts. 2 amps times 4 volts is 8 watts. 2 amps times 6 volts is 12 watts. Okay. And finally, this very last cell. So 2 perspectives. You could apply Joule's law at the point of the battery. Okay. And what would that give you? How many watts? 24 watts, right? Because 2 amps times 12 volts is 24 watts. Right? Alternatively, you say, does electricity supply match electricity demand? So what is 4 plus 8 plus 12? 24. There's 24 watts demanded and 24 watts supplied. It's a match. Okay. Thanks for that. All right. Let's switch over and look at a basic parallel setup. Let's go, let's call this resistor A, resistor B. This guy 12 ohms and 6 ohms. Let's have a battery that's 12 volts, 12-volt battery. So location, resistance in ohms, potential difference in volts, current in amps, power in watts. All right. Okay, so I gave you guys 12 ohms there, 6 ohms there. And I gave you guys a 12-volt battery. All right. There you go. Here's the setup. So first question, what is the equivalent resistance of the entire circuit? You can figure that out. Equivalent resistance. It is 4. It is 4. Good call. Yeah. So Evan says 4 ohms. Okay. How'd you know it was 4 ohms?
Did 6 times 12 divided by 6 plus 12.
Exactly. Yeah, you could just do product over sum, right? Product over sum. For if you have 2 resistors in parallel, you can do that, right? As long as you only are working with 2 at a time. Okay? So resistance equivalent is exactly 6 times 12 over 6 plus 12. That'd be ohms. So that's 72 on 18 ohms, which is like 4 ohms. Okay, yeah, so 4 ohms. Okay. The battery feels like it's pushing against 4 ohms. Okay. now I have to mention too that I always bring in this analogous story of resistors in parallel is like people teaming up to work on a project in parallel, like painting a fence. If it takes this guy 12 hours to paint a fence, this guy 6 hours to paint a fence, they work as a two-man team, they can knock out the job in 4 hours. Okay. Right. What is the voltage drop across the resistor A? It's not 36. Here. Guys, anytime you have resistors in parallel, guys, if you have a 12-volt battery, how many volts have to drop across every single one of these waterfalls? 12. Okay. 12, 12. Okay. You guys remember, okay, in parallel, the voltage drop is the same across all the resistors. They all have the same voltage going across them. This guy feels 12 volts across him. This guy feels 12 volts across him, right? It's like a pressure differential, right? Right. Right. Now, if you make it that far, then these next two columns are pretty formulaic. We got Ohm's law, I equals V over R. So 12 volts on 12 ohms is 1 amp. 12 on 6 is 2 amps. 12 on 4 is 3 amps through the battery. Right? And look, it adds up, which follows the junction rule. So I have 3 amps leave the battery. Then it hits this junction and the current splits. And 2 amps go through the small resistor and only 1 amp goes through the large resistor, right? And then it all combines back together, and the 2 down this branch and 1 down this branch make 3 amps again. Back to the battery. Is that? And power is current times voltage. So 1 amp times 12 volts, that's 12 watts demanded there. 2 amps times 12 volts, that's 24 watts demanded there. 3 amps times 12 volts, that's 36 watts. Demanded there. Okay, now that's from Joule's law perspective, right? Let's do electricity supply and demand. Right? How many watts are demanded? Wait, what's 12 plus 24?
36.
36, right? So 36 watts are demanded. And here, this box is saying that 36 watts are supplied by the battery. Okay, you see that? Joules per second, that's what watts are. You see that? You're good? You guys good on that? All right, so I want to do 2 more circuits with you guys. All right, let's do another parallel, but I'll make it a little bit fancier. Sort of, I guess. And a corresponding Kirchhoff table. All right. At 120 volts. Okay. Let's say I call this guy here. There you get some numbers. Right. Let's call this guy 30 ohms and this guy 30 ohms. Right. What if I just draw that and I walk away? Right. You guys, I want to know, what is the equivalent resistance of that entire circuit? What is the equivalent resistance of the entire circuit as I've drawn it? And it's kind of a trick question. Who sees it? What is the equivalent resistance of that entire circuit? How about this? Right. So you leave this parking garage. Let's do a traffic analogy. Right. So you're driving your car, you leave this parking garage, you're going to drive around town. Right. Drive around and say, oh, okay, I got 3 streets I could go down maybe. Right. I wonder which way I want to take to get back to the garage. Right. Look down the street, you see like 30 red lights. Like, right. Look down the street, 30 red lights. Look down the street. It's completely car-free, light-free. Ooh, which way are you going to take every time? This route right here, right? In fact, does 100% of the traffic go along that branch? That has a name, starts with an SH. It's called a short. Right? That is a short circuit. That's right. now I'm going to add to this so it's not a short circuit anymore, but I just want you guys to see that be the case. Right? As I've drawn it, these two guys are not even part of the circuit. If these are light bulbs, they don't even light up. Right? All the current would flow around that short. Okay. Now I'm going to modify this so that's not the case. Right? Let's throw in another 30 ohm resistor right here. 30 ohms. Okay. I'll call this A, B, C, and the battery. Okay. Okay. Guys got that? Okay. And then location. Okay. A, B, C, and the battery. Okay. So I gave you some values. So go ahead and write those in. Got 30 ohms on each one of these guys. Okay. And we got 120 volts supplied. Okay. All right. That's all the given information. All right. So first question, what is the equivalent resistance of that entire circuit? Equivalent resistance of the entire circuit. It is 10. Yeah, Bella says 10 ohms. Okay. All right, so I'll take you guys through 3 different ways you can get 10 ohms. Right? One is if you think about the story, 30 hours to paint a fence, 30 hours to paint a fence, 30 hours to paint a fence, 3-man team. Could they knock out that job in 10 hours? Right. That's what that would be, right? Be like a third of your time. Or you can, where is it? Okay. You can use this reciprocal method. I'll go ahead and just type this in my calculator. Okay. I could go 1/30 plus 1/30 plus 1/30. Okay. Now that's not going to be the answer yet. I still have to take the reciprocal of that, don't I? Reciprocal. So 1 over that answer is, and that is 10 ohms, but that's what Bella said anyway. Okay. Another way, you could do product over sum, but if you do that, you can only do 2 at a time. So let's do that. Right, so voltage source here, let's fly over to the opposite side, to the equivalent circuits going back. Okay. What's product over sum of 30 and 30? 30 times 30 over 30 plus 30 is like 15. Okay. So it's as if there's a single 15 ohm resistor here, and that would be in parallel with this guy. So it's 15 times 30 over 15 plus 30. Oh, that's 10. Boom. Okay. So there you go. There's 3 different stories that all lead to the same 10 ohm total resistance. Right. Next column is how many volts drop across resistor A? What's the rule for resistors in parallel every single time? Yeah, it is 120 volts. Right? Because 120 volts pumped up. Every single one of these waterfalls is supposed to be 120 volts down. Right? Even if they were different resistances. Now I made them all the same resistance, but even if they were different, that would still have to be true. Right? So this 120, 120. Right? Right. So loop rule, 120 up, 120 down, 120 up, 120 down, 120 up, 120 down. That's Kirchhoff's loop rule. Current is I equal to V over R. Okay. So 120 volts on 30 ohms, that's like 4 amps. That's also true here, and it's also true here. Okay. How about the battery? How many amps are supplied by the battery? 12 amps, right? 120 volts on 10 ohms, 12 amps supplied by the battery, right? So here's the story. 12 amps leave the battery, 12 amps. Then it splits 3 ways. And since these resistors are all the same, it splits exactly evenly. So now you have 4 amps this way, 4 amps this way, 4 amps this way. Okay. And finally, power is current times voltage. Current times voltage. That 480 watts. 480 watts. 480 watts. Right. And okay, you could do, see, 12 times 120. Well, I know 12 times 12 is 144. There's a 0 in there, so 10, so 1440 watts. Okay. Now, let's check supply and demand for electricity, see if that works. Okay. because I know the electricity demanded is 480 watts times 3. That should be 1440 watts supplied. Let's see if it's a match. Boom, it is. It's a match, right? Some of these 3 electricity demanded matches this electricity supplied. Okay. Guys, good there? All right, are we good? All right, let's do one more circuit, and this will be a bit of a challenge when I'm trying to build up, make this a little bit harder as we go. I got 24 volts supplied. Let's call this A, B, C, and D. Let's put 12 ohms right there. And then how about 4, 4, and 4. Sure, right there. Okay. Make myself a Kirchhoff table. Make it up. 4. Oops. So different location, resistance in ohms, potential difference in volts, current in amps, power in watts. I got A, B, C, D, and the battery. I gave you all the resistors, and I gave you the voltage supplied by the battery. All right, there's the setup. All right, so it's the trickiest one we'll do for review, but see a quiz question like this, and this will probably be the hardest type quiz question I would ask you, but open notes. Right? Right. So remember how we found the equivalent resistance for these more complex type circuits? I mean, I see some series, I see a parallel set, right? See both of those. So you find your voltage source, you fly over to the opposite side of the circuit, and you find equivalent resistances working your way back. Right. So first thing I see is that A, B, and C are all in series, right? So can you just very simply add those together? And how many total ohms is that? Yeah, 12 ohms. You guys see 12 ohms, right? Now that is in parallel with this 12 ohms, or I should have asked you guys, but you guys see the current would split right there, right? Which means that these 3 guys are in parallel with this guy. Guys, what is this 12 and this 12 in parallel with each other? What is 12 and 12 in parallel? It takes me 6, yeah, 6, right? There you go, 6. Right? 6 ohms. Right? It takes me 12 hours to paint a fence, and combination of other people, 12 hours to paint a fence. Altogether, it's so like, if you team up, then it's like half the time for each individual, right? Or you could do product over sum. Okay, let's do product over sum. So we've got 12 times 12 over 12 plus 12. 12 times 12 over 12 plus 12. That 6. Right? 6 ohms. Right? So the battery feels like it's pushing against 6 ohms of resistance. Right, voltage drop. Now, the one I think is really obvious for voltage drop is going to be resistor D. So let's do resistor D first. Okay. Do you guys see a loop right here? You guys see a loop? Here's 24 volts up. So how many volts down right here? 24. 24 up, 24 down. That. So resistor D has to be the full 24 volt drop. Right? Wouldn't that be the case? Right. Oh, you know what? I do have a poster for this. I almost forgot. Let me find. Where's that poster? here somewhere. Oh wait, never mind. I was thinking of this, but this is not exactly the same thing. Oops. Okay, scratch that. Never mind. All right, but this would be like one giant waterfall that matches the same height as the pump, right? So battery resistor. All right, now I know from this junction to this junction, we have a 24-volt drop, right? 24 volts drop across that guy. And there's also 24 volts drop going around this way. And I made each of these resistors equal to each other, like equivalent. So do you think that the voltage drop is going to happen a third of the way, a third of the way, a third of the way? Right, which would follow exactly this right here. I mean, these three guys are in series with each other. So I'm thinking more like this. Right? So guys, what's 4 over 12? 4 over 12? That's a third, right? 4 over 12 is a third. What is a third of 24 volts? 8 volts. 8 volts. Okay. And since they're all the same, you think it's 888? You think? Okay. Now that part of the circuit, now this is not the entire circuit we're doing, but that part of the circuit is kind of like this. Actually, I could modify this real easy, make it look like what you actually do have, which is just throw in an extra waterfall right here, or throw in a waterfall right here. That would be the same things you guys have, right? Got like a 24 volt drop there, and this drops 8, 8, 8. Right? Right, current in amps. Is current equal to voltage on resistance? Right, is that true? So got 8 volts on 4 ohms. Is that called 2 amps? Right? 8 on 4 is 2. 8 on 4 is 2. Right on. All right, how about resistor D? How many amps go through resistor D? Did I do that right? Yeah, that would be also 2 amps that way, wouldn't it? Okay, yeah. Because here, think about this. Here comes the electric current going around. It hits this junction, it's going to split. It looks to the left and sees 444, that's 12 ohms. Looks to the right, sees also 12 ohms. So it should split exactly in half. 2 amps go that way. 2 amps go that way. Right? Here's 2 this way. Here's 2 that way. Right? How many amps through the battery? What's 24 on 6? 4, right? Still Ohm's law, just at the point of battery. Right? Or if you like, there's 2 amps that come, so 2 amps went that way, 2 amps went that way. Okay? There's 2 amps down this branch. There's 2 amps down this branch. They combine to make 4 amps. 4 amps. Okay? And last column, power in watts. Did you do power is current times voltage? So 2 amps times 8 volts is 16 watts. Okay. Also true for that one and that one. Be true. Okay. Okay. How about resistor D? What is 2 amps times 24 volts? 48 watts. All right. Be true. All right. And finally, through the battery, how many watts supplied by the battery? 96. Okay. You could go 4 times 24 is 96. You do that. Okay. Or you could add up all the electricity demanded, 16, 16, 16, and 48. That adds up also 96. Here, let me confirm that. 16 times 3 plus 48 is in fact 96 watts. So electricity supply matches electricity demand. All right. Okay. You guys be able to do that? Okay. All right. So kind of ends recording, but I'm going to switch over and show you guys a short video to cap off the class.